Hello and welcome back to the lab. Today on the bench we have two of my favorite Hewlett-Packard instruments. On the top we have the HP 5328A counter, and underneath that we have my HP 3325A synthesizer. These are two of my favorite HP instruments. I use them all the time. They're both in perfect working condition, but they do have a problem. And that problem is very typical of all Hewlett-Packard instruments of that era, or many of them anyway, and that is noisy fans. In part one, we replaced the noisy fan in my HP 3455A voltmeter, and now we're going to work on replacing the noisy fans in both of these instruments. So let's go. Okay, so to replace these fans, uh, other YouTubers and others have recommended these Noctua fans, and I tried them in my 3455A voltmeter, and it worked out very well. So I'm going to use the same fans to replace the fans in my 5328 and in my 3325. For the frequency counter, the 5328A, we have this 60 millimeter by 25 millimeter deep 12 volt DC fan. Very high quality fan, very inexpensive, and almost completely silent. That's what I really like about this fan. These really worked out well, so I'm going to use it again. For the HP 3325A, we have this 80 millimeter by 25 millimeter deep 12 volt DC fan. Also Noctua, the same thing. Almost completely silent. Very high quality, very high performance, but almost completely silent. And that's what I like. Now, the, the only thing I don't like about these fans, of course, is their characteristic tan and brown color scheme. I mean, I wish they were black, but this is their sort of their trademark color. So that's what we have to live with, I guess. Um, it'll be inside the instrument anyway, so no one will really see it. But I wish they came in black. But anyway, um, these are the fans I'm going to use, and I really like them. So that's what we're going to do. Okay, so let's start off with the bad news. The bad news is in the 5328A counter, I have already replaced the fan, and I didn't make a video of that process. So I'm going to make a video of it now, and I'll just walk through the steps that I took to swap out the fan with the new silent fan. So let's get started on that. Okay, first let's take a look at the fan that I pulled out of the 5328A counter. This is the fan. It's the exact same fan that was used in the 3455A digital voltmeter. And I have a link to that one in the description of this video. I would link to that video in the description of this video. Um, this is a kind of an interesting device. Let's see if I can zoom in a little bit. It has um, four wires. Three of the four wires are um, three separate pulsed uh, phased uh, stepping pulses. That's 120 degrees out of phase. So first it pulses one phase, then the next phase, then the third phase, and over again. And the fourth wire is a common to all three phases. So that's what drives this motor. The frequency at which you step through these determines the speed of the motor, of course. Now this one comes with the module that actually develops those three stepped pulses, those three phased stepped pulses. Um, Inside of this module is the circuitry that produces those waveforms to drive the motor. Those pulses have an amplitude of about 12 volts. So this really is kind of a 12 volt motor, you could say, but it has three phased stepped inputs. And those are all driven by this module that was also inside the 5328A counter, and I just removed that. Now, the input power supply to the three phase stepped ring modulator module is uh, plus 15 volts DC, and that comes through the red wire and the blue wire to from 15 volts. That's in the 5328A counter. So I removed all of this. I'm not going to use this thing, and I'm certainly not going to use this noisy fan. It works well, but it's very, very noisy. Actually sounds like a jet engine. Now, this fan blows toward the motor. So the direction of the airflow is in this direction. Now, the interesting thing about the 5328 counter is most instruments have air drawn in with the fan and exhausted through other ports within the instrument. The 5328 counter is the opposite. It actually blows, excuse me, it actually blows outward. So it's really like an exhaust fan. So it actually has to blow toward the motor. And what that means is the 5328A has to have the motor positioned to the back of the instrument. Um, it was actually mounted on these metal spacers to stand off uh, the fan from the rear of the instrument. And these metal spacers were mounted with rivets to the rear panel. And I had to drill those rivets out and remove these spacer standoffs from this fan because I won't be using those either. So this is the old fan that I pulled out. Now let's take a look inside the 5328A and see how I've installed the new fan. Okay, so here's a look at the new Noctua fan installed at the rear of the 5328A. This fan also blows outward, okay, so it's still an exhaust fan, but there is no motor separate. The motor is all internal to the hub of the fan itself. So there's no need for those standoffs, and that's why I've removed them and fastened it directly to the rear panel with a few, I guess they're 632 screws or something. Now this fan is a 12 volt DC fan. There's no need for that three-phase stepping motor or anything like that. But this 5328A does not actually produce 12 volts DC. It produces 15 volts DC through this twisted pair here, the blue and red wires. You can get 15 volts DC. The fan will probably operate just fine at 15 volts, right? But I didn't want to take a chance. So what I've done is I installed a 7812A voltage regulator and bolted it to the rear panel directly. Um, the heatsink mounting, the tab mount, is actually the middle wire, which is the common wire or the ground on the 7812. So I, I feed the 7812 chip with 15 volts DC from the motherboard of the counter, and the output of that is a regulated 12 volts DC, which goes directly to the fan. So now every time I turn the instrument on, uh, the fan receives 12 volts DC and it should power up. Now this instrument, of course, is in standby all the time because it has over here the oven control crystal oscillator, which stays on all the time whenever the instrument is plugged in. The oven stays heated to keep the crystal at a constant temperature. But the fan only comes on when you turn the power on the instrument. So let me turn that power on now, and we'll demonstrate the new fan. If I can get it plugged in, of course. Here we go. All right. Turn the power on. There's the new fan running. Very, very, very silent. But there is still considerable airflow. It's blowing outward. Rather unique for the 5328 to have a fan that blows outward. But this one does. And that means, of course, that there's no dust filter on the rear panel because you don't need to filter the dust as it leaves the instrument. only if it's coming into the instrument. So there's no dust filter, no fan filter to worry about on this unit. So that's the Noctua fan installed in the 5328A frequency counter. Now, to replace the fan in the 3325A synthesizer, we're going to have to do things a little bit differently. So let's take a look at the schematic for the 3325. Here we have the fan motor. They're calling it B1 on the schematic. It connects here to this Molex style plug onto the power supply board. It's actually a 120 volt AC fan. And we want to replace it with a 12 volt DC fan. So we have to do some conversion to drop the 120 volts AC down to 12 volts DC. The fan, one wire of the fan connects directly to the hot side of the mains input after going through the fuse, of course, right across the primary of the main power transformer. So it's always connected to hot through the fuse and the line selector switch. The low side of the fan blower motor connects to this normally open set of contacts on this relay K1 on the power supply board. The other end of that relay contact goes to the neutral side of the mains power supply line voltage. So when the relay is energized, you have 120 volts AC across the blower motor and the blower starts blowing. Okay, to energize that relay, the upper end of the relay is connected to the unregulated side of the 5 volt DC voltage regulator. So it's connected to plus 9 volts DC. There's always plus 9 volts DC at this point whenever the instrument is plugged in. And the lower side of the relay connects to this node over here, which also connects to the main power switch. To turn the instrument on, you click this switch and it grounds this node, connects this node to the chassis common, the low terminal. And that completes the circuit, energizing this relay and closing those set of relay contacts to supply 120 volts AC to the blower motor. In addition, it grounds this node, which activates the main power supplies, turns on the regulators. But we're interested today only in the fan motor over here. So what we have to do is convert 120 volts AC into 12 volts DC. In order to do that, I decided to go with a linear regulator circuit. I didn't want to use a switching power supply regulator because that might introduce extra noise into this instrument. So I decided to go with your good old-fashioned 12 volt linear regulator circuit. So we're going to need a step-down transformer, and I bought this one. I guess the red is primary, 120 volts. Blue is secondary, it's 12 volts AC that will come out of this power transformer, and we'll hook the primary up directly to the Molex connector on the power supply board, so that we'll supply 120 volts AC to the primary of this transformer whenever the power switch is turned on. And I was going to actually design a 12 volt linear regulator circuit and make a circuit board, but I decided you can buy them I paid, I think, like $2 for this little one. And so that's what I'm going to use. This one has a full wave bridge rectifier right here, and has a 7812 12 volt DC voltage regulator, and has some filtering and bypass caps on the input and output to that 12 volt regulator. And the whole thing, including the little screw terminals for inputs and outputs, cost me, I think, like $2. So it wasn't really worth trying to design and build my own regulator circuit when there's one right here for $2. So that's what I'm going to do. So I will connect the output of the power transformer to the input of this, and the output of this will go to my new Noctua low noise fan. So let's open up the 3325 and figure out how I can get these components installed in that instrument. Okay, so I've removed the top and bottom covers of the instrument. There's the fan that we're talking about here, that pesky little bugger. Here's the power supply board. Under here is the, here, let's pull this ribbon cable. There we go. That's the ribbon cable for the HPIB connector on the rear panel. Underneath that is the power supply board. Here's the relay, the K1 relay that we were talking about that actually energizes to turn on the fan. And the fan is plugged in over here to this 2-pin Molex connector. So this is where we're going to connect our primary of our second transformer. We have to find a place to mount the transformer. The transformer I got is actually quite large. It's a little bit overkill, but it's what I bought. It says 10 VAs. That's what is that? 800 milliamps or something like that, I guess. The fan draws, I think, 90 milliamps. It doesn't need anything near 800 milliamps. But this is the transformer we have, so we have to try to squeeze it in there. You know, the new fan is not as deep as the old fan. The old fan, I believe, is like 30 millimeters deep, and the new one is only 25 millimeters deep. So we'll have an extra 5 millimeters. There will probably be enough room to mount the power transformer right here behind the fan. I think. I mean, I hope so anyway. This part of the chassis is not actually connected to the outer chassis, the earth ground. This inner chassis is the low common ground, which is common to all the low inputs on the, like the outer shells on the BNC connectors and so forth. And it's common to all these ground planes on all of the circuitry, but it's floating and isolated from the outer chassis ground, the earth ground. There's actually, you can have a 500 volt potential between these 2 points. You can apply an external 500 volt potentially between these 2 points. It doesn't generate any voltage like that on its own. But the point of saying that is that I want to insulate the transformer case from this inner chassis. So I'm going to have to mount it using some sort of insulation technique, because we don't want to connect this part of the chassis to this part of the transformer to the chassis, inner chassis ground. We want to actually connect it to earth ground, probably through a separate wire. So I'm going to have to figure out a way to do that. I think if I remove this little wire clip clamping thingy here, we can probably get the transformer in there and the 12 volt rectifier and regulator board in there as well. Once we get the narrower fan in place to replace the 120 volt AC fan. All right, let's get started by pulling out this old fan. By the way, I am going to keep all of these old parts so that if I ever want to return them, restore it back to its original condition, I can do that, removing the new fan. I mean, I don't see that happening, but I may want to at some point restore them back to original factory condition. Or if I'm going to sell it, maybe the next person will want to do that. I don't really know, but I am going to keep all these components that I remove from these instruments to do this fan upgrade. All right, let's pull this fan out and get the new one installed in its place, and we'll see what kind of room we have here to mount the rest of the components. So I removed the fan filter and its little holder off the rear panel and disconnected the hardware from the fan and removed it. Um, Inside is this strange kind of galvanized chicken wire screen. Um, I, I used to have a hamster cage made out of this same material. I, I really can't believe that Hewlett Packard would have used this for their fan filter setup, but that's what they used. I guess I'm going to reuse it to put the new fan filter in. Now, on the Noctua fan, there's an arrow indicating the airflow direction pointing this way. You want to make sure that the fan is blowing inward because otherwise the filter will not be filtering anything. So you don't want the fan like an exhaust fan blowing outward. It should be blowing inward. So make sure when you mount the replacement fan that the arrow is pointing inward. Okay, so I've bolted in the new fan where the old one was, and it is definitely narrower and gives us some more room. And I removed the little cable clamp thing that was fastened to the chassis with double-sided foam tape. I just popped it off, and but even still, I don't really think there is quite enough room to comfortably fit the new transformer in that place over here. It's just going to be a little bit too tight, I think. A little bit too tight. So I could either look for a smaller transformer, which I could easily do because this transformer is quite large and heavy and really overkill for the purpose we're going to try to use it. But I think I want to just continue to use this because I already have it and I don't want to invest a lot into this project. Um, so I think that if we flip the instrument over and take a look at the other side, we might have some available space. Let's do that. So on the other side, um, this space that is here is for the optional OCXO oven control crystal oscillator. Uh, that's meant for high frequency precision and stability, right? Um, this instrument does not have that option installed. So this space is open. I use an external reference on this 3325 for an external frequency reference for my frequency accuracy. So I don't need an oven control crystal oscillator. So that option is not installed and this space is all open and available. See, I've also removed a cable clamp with double stick tape right here on this spot here. But now there's absolutely a ton of room to put the transformer and the little power supply board and get everything wired up. There's plenty of room. So this is where we're going to mount our components for the power supply, for the 12-volt power supply. So I marked and drilled holes for the to mount the power transformer and to mount the 12-volt regulator board on this part of the inner chassis. And I used some brass standoffs on the diagonal corners of that 12-volt regulator board to mount it to the chassis. And I mentioned before that I wanted to somehow insulate the frame of the transformer from the inner chassis so that I can ground the frame of the transformer to the outer chassis, which is the earth ground, um, basically just for safety purposes. So I came up with a solution for that also. So I found this piece of, it seems to be probably polyethylene or something like that. It's one of those page protectors, page separators. I don't even know what they're called. That inserts in a three-ring binder. It's a thin piece of plastic, probably polyethylene, and I'm going to use that as my insulator uh, to isolate the transformer from the inner chassis. I'll just use the transformer as a template and cut out a little um, like a little gasket type thing to fit underneath the transformer to insulate it so that when I put the screws through, they will not ground this part of the frame on the transformer to the inner chassis of the 3325. So there is the little insulating spacer that I made, the little black spacer. And now I can mount the power transformer on that. And I will have a matching insulating spacer on the opposite side for the nuts underneath that the hardware will go through. Now I can mount the power transformer. And I attach the transformer from the other side of the chassis with a pair of nuts and two small pieces of that same black plastic insulation. I ran a ground wire from a lug on one of those nuts to the main ground lug on the back of the rear chassis. I verified with my ohm meter that I do have continuity between the frame of the transformer and the outer chassis, which is earth ground, but I have complete isolation from the inner chassis, which is the common low terminal of all the circuits inside the instrument. These two are still insulated from one another, these two chassis. And then I wired up the secondary of the transformer to the input side of the 12-volt regulator and the output side of the regulator to the fan connections. And on the other side, I wired up the primary of the transformer back into the Molex connector where the original 120 volts AC came out to drive the fan. And now all that's left to do is plug it in and turn it on, and let's see what happens. Okay, ready? Here we go. 3, 2, 1. It works. And it's like almost completely silent. Wow. Very good. All right. That's the fan replacement on the 3325. And of course, we have Hopper, our new lab manager, inspecting all the equipment and making sure that we have everything we need in good working order. Thanks for your help, Hopper. Okay, so there you have it. A fan replacement in the 5328A counter and the 3325A synthesizer. After final approval from Hopper, our lab manager, these instruments are ready to go back into service. Thanks for watching. Please like and subscribe, and stay tuned for more fun videos with vintage HP test equipment and other fun stuff. Thanks again.